The next 20 years will change more than the last 2,000. Not because of a single invention, but because several revolutions are colliding at the same time. For most of human history, progress moved slowly. Then, energy accelerated everything. Muscle, animals, wind, coal, oil. Each time we unlocked more energy, civilization expanded. Today we are approaching a new threshold, one that removes the ceiling entirely. Nuclear fusion. For decades, fusion was a joke, always 30 years away, a scientific mirage. That joke is no longer funny. In early 2024, a French fusion reactor sustained a plasma at 50 million degrees Celsius for over 20 minutes. That is more than 3 times hotter than the core of the sun. And it shattered the previous record. At the same time, private investment in fusion has passed $10 billion. Companies like Commonwealth Fusion Systems are already building pilot reactors. Commercial fusion plants are now realistically projected for the 2030s. Google has signed agreements to buy fusion-generated electricity. MIT models suggest fusion could supply a massive share of global power by the end of the century. This time is different for one reason: high-temperature superconducting magnets. These magnets allow reactors to be smaller, cheaper, and more controllable. Tokamak Energy recently demonstrated magnetic fields strong enough for grid-scale fusion. Fusion is no longer a distant theory. It is an engineering timeline. And energy is only the first layer. Because while we are learning to build artificial stars, we are also rewriting the code of life itself. CRISPR, a word that sounds harmless, but it represents the most powerful biological tool ever created. 2 years ago, the first CRISPR-based therapy was approved to cure genetic blood diseases in a single treatment. Diseases that were once lifelong and fatal, eliminated with one injection. Soon after, researchers demonstrated a gene-editing therapy that permanently reduces harmful cholesterol levels by nearly 50%. No daily medication, no ongoing treatment. A permanent change to your DNA. And recently, AI systems have entered the process. At Stanford, researchers combined CRISPR with machine learning models that design genetic experiments automatically. What once took months of trial and error now takes days. In one case, a student successfully disabled multiple cancer-related genes on their first attempt. This is not biology progressing slowly. This is biology accelerating, and it goes further. Researchers have already reactivated dormant genes that humans lost millions of years ago. Genes associated with resistance to certain metabolic diseases. We are no longer just repairing the human genome. We are expanding it. And while ethical debates struggle to keep pace, not every nation is waiting for consensus. The first country to fully master genetic engineering will not ask permission from the rest. But even this is not the main driver of acceleration. That role belongs to artificial intelligence. In early 2025, leaders at major AI labs made unusually direct statements. They no longer speak about if general intelligence is possible, but when. Some predict systems matching or exceeding human-level cognition before the end of the decade. This does not mean chatbots that answer questions. It means systems that can reason across domains, improve themselves, and solve problems humans cannot. And pieces of that future are already here. AI agents now operate semi-autonomously. They receive objectives, write and modify code, search the internet for hours, and coordinate complex workflows. Some cost hundreds of dollars per month, and companies are still adopting them because the productivity gains are real. This has triggered a new kind of arms race. Not for data, not for talent, for energy. Training and running advanced AI models requires enormous power. Microsoft, Google, and Amazon are investing billions to secure long-term energy sources, including nuclear fusion, specifically to feed AI infrastructure. This is where the convergence begins. AI requires energy. Fusion provides energy. AI accelerates fusion research, and both accelerate biology, materials science, and robotics. The system feeds itself, and humans are not staying outside of it. In 2024 and 2025, brain-computer interfaces crossed a critical line, not in theory, in practice. Neural implants were successfully tested in multiple patients. People with paralysis used thought alone to control computers, write text, and play games. One patient with neurodegenerative disease narrated and edited a full video using only neural signals. An AI model reconstructed his original voice from recordings made years earlier. Other companies have developed implants that can be inserted through blood vessels, avoiding open brain surgery. Several have received regulatory approval for extended human trials. At the same time, humanoid robots are leaving laboratories. Tesla plans to deploy thousands of humanoid robots in its own factories. Other companies are testing similar systems in logistics, manufacturing, and service roles. Mass production is scheduled to begin within the next 2 years. These machines will not just follow scripts. They will be guided by AI systems trained in simulation and real-world environments simultaneously. Now step back and observe the structure. Unlimited energy enables unlimited computation. Unlimited computation enables superhuman intelligence. Superhuman intelligence accelerates biology and robotics. Neural interfaces connect humans directly to these systems. Robots execute decisions physically at scale. This feedback loop has a name: technological singularity, a point beyond which prediction becomes unreliable, because change accelerates faster than understanding. The question is not whether this will be comfortable. It will not. Our political and economic systems were designed for a world with scarce energy, slow innovation, and human labor at the center. That world is fading. Jobs, value creation, even identity will be redefined under conditions humanity has never experienced. So how do you prepare for something you cannot fully predict? First, do not assume stability. Systems that appear permanent are often the most fragile during periods of acceleration. Second, understand that AI is not a wait-and-see technology. Those who integrate it early build compounding advantages. Delays today create gaps that cannot be closed later. Third, learn how to think with these tools. Not necessarily how to engineer them, but how to collaborate with them. History rarely rewards spectators. Moments like this are rare. The printing press, the Industrial Revolution, the Internet. Except this time, multiple revolutions are arriving at once. Every generation believes it lives in extraordinary times. But occasionally, one is right. This transmission ends here. The next one is already forming. Stay aware and subscribe to Remain in the Signal.